Hello everyone, I am Dr. Sonal Jain from Department of Anthropology, University of Delhi. In this lecture series of Forensic Science, today we will discuss about Introduction to Forensic Science. Starting with, whenever you have excluded the impossible, whatever remains, however improbable, must be the truth. This quote was given by Sir Arthur Conan Doyle. He was the first novelist and physicist who wrote the crime fiction novels, and he was the pioneer of crime fiction novels. Now, what is forensic science? Forensic comes from the Latin word forensis, which means of a form or place of assembly. Forensic science is the application of science to matters of criminal and civil law. An applied science that is multidisciplinary and multidimensional in nature. The forensic science, this nature of science has no absolute authoritative solutions. All it offers is objective information on what occurred at crime scene. So basically in forensic science we apply the knowledge of physics, chemistry and biology to solve the cases and to solve the crime and to know the possibilities whatever have occurred at the crime scene. The concept behind the forensic science. Whenever two objects, animate or inanimate, microscopic or macroscopic, in whichever physical state they come in contact with each other, there would be an exchange of material. These materials are also known as the physical evidence, and the analysis of these physical evidence forms the basis of forensic science and which helps us in solving the crime. Forensic science essentially deals with the laboratory examination of different types of physical evidence encountered at the scene of crime. Physical evidences are always preferred over human witness because evidence never lie, but human can and they do. The forensic science can be viewed as a tripartite structure consisting of three major structures: collection, examination and presentation. Collection begins at the crime scene, which pertains to the crime scene investigation, where we collect various physical evidences. These physical evidences then go to the forensic science lab, where these evidences are examined. Examination, which pertains to the evidence analysis using various preliminary and confirmatory tests, and the presentation, which pertains to the court of law. Every forensic science expert who has done the analysis or the examination of that particular evidence, he has to present his report in the court of law. A forensic case will involve all aspects of each of the three structured elements that is we discussed: collection, examination and presentation in the court, each being as important as the other. A forensic science lab or FSL partakes the relevant jobs of examination and analysis, and the report will be presented in the court of law. Forensic science is the science of comparison between unknown and the known. The unknown evidence, which is from the crime scene, it is compared with the known evidence which we collect from the suspect or various suspects. As we have discussed that the presentation will be there in the court of law, there are certain laws which pertain to the scientific evidence. There are certain laws in which various crimes have also been defined, like IPC 375 and 376, the rape has been defined, the punishment of rape has been defined. Similarly, we have Indian Evidence Act, where the definition of expert is defined in the section 45. We have Criminal Procedure Code section 293, which defines the document. Then Indian Evidence Act 47 and Indian Evidence Act 73. Let's see what this law pertains to. Section 45 of Indian Evidence Act. When the court has to form an opinion upon a point of foreign law or of science or art, or as to identify handwriting or any fingerprint impression, the opinion upon that point of persons especially skilled in foreign law, science and art, or in question as to identify of handwriting or fingerprint impressions are relevant facts. Such persons are called experts. The court may, if it thinks fit, summon and examine any such expert as to the subject matter of his report. So the expert who has analyzed the particular evidence in the forensic science lab, he may be summoned by the court, and then he has to present his report into the court of law and defend his report. Where any such expert is summoned by a court and he is unable to attend personally, he may, unless the court expressly directed him to appear personally, depute any responsible officer working with him to attend the court, if such an officer is conversant with the facts of the case and can satisfactorily dispose in court on his behalf. Then the section 293 CRPC. Any document purporting to be a report under the hand of a government scientific expert to whom this section applies upon any matter or thing duly submitted to him for examination or analysis and report in the case of any proceeding under this code may be used as evidence in any inquiry, trial or other proceeding under this code. Then the section 47 of Indian Evidence Act, which allows an individual to express an opinion about the genuineness of writing if the said individual is acquainted with the writings of the person concerned. Section 73 of Indian Evidence Act says, the court may direct any person present in the court to write any words or figures so written with any words or figures alleged to have been written by such persons. This section also applies with necessary modification to fingerprint impressions. Now, we will discuss various principles and laws of forensic science on which this science is based. The first basic principle of forensic science is the law of individuality. Then we have principle of exchange, law of progressive change, principle of comparison, principle of analysis, law of probability, and law of circumstantial facts. Going with the first principle, which is law of individuality. Every object, natural or man-made, has an individuality. It cannot be duplicated in any other object, neither by natural means nor by artificial means. For example, every person, they have unique fingerprints and can be individualized by fingerprint examination. This law of individuality is the basics of forensic science. Each and every thing is unique and this individuality cannot be replicated. That forms the basis of forensic science. Then we have principle of exchange, which is also known as Locard's principle. Locard's principle is by the name of Dr. Edmund Locard. When a criminal or his object of crime come in contact with victim or objects surrounding him or his instrument, picks up traces from the same contact. If a suspect or if a criminal visits a crime scene, there are higher chances that he might leave his fingerprints, shoe prints, his footprints or any other hair or fiber at the crime scene. These evidences then may be collected by the investigator and those are analyzed by the forensic scientist in the forensic science lab. For example, shoe prints, blood, fingerprints, tire marks. Tire marks usually in the cases of hit and run cases. There may be also have paint chips, etc. And these are the physical evidences which are later on collected and then examined by the forensic scientist. Now moving to the third principle, we have law of progressive change. It states that everything changes with the passage of time. For example, the scene of crime undergoes rapid changes, so the evidence should be collected as soon as possible. Similarly, the body on the crime scene, we have the dead body, the corpse we call it, that also goes so many changes. So the evidence should be collected as soon as possible from the crime scene. Otherwise, the progressive change may destroy our evidence. Law of progressive change also inhibits uniqueness in some materials, like some individual nicks, cuts and tears can be found in shoes, which can help in the identification of that particular shoe or that particular tire. For example, we have a tire and a shoe which are manufactured from the same company. They have the same class evidence. But with the law of progressive change, there might be some nicks and cuts in the tires or in the shoes which may individualize that particular shoe or tire and help in individualizing that particular evidence. Moving on to the fourth principle, which is the principle of comparison. Forensic science is the science of comparison, and only like can be compared with like. DNA evidence can be compared with DNA evidence, tire marks can be compared with tire marks, fingerprints can be compared with fingerprints. It emphasizes the necessity of providing like samples and specimens for comparison with the questioned samples. For example, if the blood found on the crime scene is A positive, then it cannot be compared with the person having the other blood group. A person having A positive blood group can be compared with the same person having the A positive blood group. Similar goes with the B positive can be compared with the B positive blood group. If the blood group doesn't match, then there is no need of continuing the analysis or go for the DNA typing, as the blood group is a class evidence, and if it is not matching, then we can go and look for other suspects, and similar can be compared with similar. The fifth principle is principle of analysis. This principle states that there can be no better analysis than the sample analyzed. It emphasizes the necessity of correct sampling and correct packing for the effective use of expert. For example, blood drops found in two sites at the same scene may not belong to one person. So, this is the mind of the investigator, that he should collect the two blood samples from the same crime scene from the different spots in different packets or different vials, because they might belong to the different persons. Same goes with if we discuss about any rape case and we have the sexual offender's clothes having semen sample, and so those samples with the blood samples and the semen samples, they should be collected in different packagings. They should be packed in different vials and should be analyzed as two different specimens. The sixth law is law of probability. All the identification indefinite are made consciously or unconsciously on the basis of probability. For example, an unknown woman is found murdered in a farm. The dead body of that woman had a gold-plated tooth, healed foot fracture, and a tattoo on her left arm. A woman with the similar characteristics was also reported missing. There are high chances that the unknown corpse is of that missing woman. The probability of that corpse being of another woman will be 1 in millions, and the identity of that unknown corpse is being established. Now, the seventh law or principle is the law of circumstantial facts. Facts do not lie. Man can and do. Importance of circumstantial evidence is as good as real evidence. Oral evidence depends upon many factors such as power of observation, assimilation, autosuggestion, etc. So, circumstantial evidences are also considered along with the analysis of physical evidences. Going forward, forensic science thus is used for recognition, individualization, identification of pieces of evidence collected from the crime scene using these principles of forensic science in the court of law. Now we move forward towards the history and development of forensic science. Major developments in the history of forensic science. In the 700s AD, Chinese used fingerprints to establish identity of documents and clay sculptures. In the 1000 AD, Roman could determine that bloody palm prints were used to frame a man in the brother's murder. In 1149, King Richard of England introduced this forensic science and investigation was conducted on a questionable death. In 1200s, a murder in China was solved using the blood residue of a sword of a man in the community. In 1598, Fidiglas was first to practice forensic medicine in Italy. In 1670, that is a major breakthrough. Anton van Leeuwenhoek constructed the first high-powered microscope, and this microscope is further used not only in forensic science but all other applied sciences. With this microscope, there are certain microscopic tests we conduct, and that gives us conclusive results about various biological fluids and their examination. In 1776, Paul identified the body of General Joseph Warren based on the false teeth he had made for him. That is a classical case of forensic odontology where a person was identified on the basis of false teeth. In 1784, John was convicted of murder because of wad of paper matching to a piece of paper in his pocket. In the case of glass and paper analysis, we always go for the match or tear analysis, and then we can conclusively tell whether the glass piece or the paper belongs to the same glass or same paper. In 1859, Gustav Kirchhoff and Robert Burman developed the science of spectroscopy. Spectroscopy is one of the major techniques which is being used in forensic science. This spectroscopy is used for my spectroscopy is used for the various analysis of petrol, kerosene and gasoline. In 1864, crime scene photography was developed. This is also one of the major breakthrough, as the photographs which the crime scene investigator takes at the crime scene, that is the only way, that's how the forensic science experts can look at the crime scene. The photography is done from the wide angle, from the close angle, and that is the only one way where we can bring crime scene to the forensic science lab. Then in the 1879, Alphonse Bertillon, he devised a system of anthropometric measurements, where that is the first identification system, major build identification system, through which we can identify a person. He has included major features in this system, for example, the height of the person and the various marks, the distance between both the eyes, the distance between various arms and the hands, and that is still used for the identification of a person. Then in the 1896, Edward developed and classified system for fingerprint identification. Fingerprint is one of the major evidence in forensic science because this is the only evidence where we can individualize a person and not even twins have same fingerprints. Then in the 1900, Karl and Steiner identified human blood groups. With the identification of human blood groups, we have A positive, B positive, AB positive, O positive blood groups, and that builds a major breakthrough for the identification of blood group and identification and individualization of a person. Then Edmund Locard in 1904 formulated his famous principle, every contact leaves a trace, and that forms the basis of forensic science. In 1992, Francis Aston developed the mass spectrophotometer. In 1959, James Watson and Francis Crick discovered the DNA double helix. This double helix model is a breakthrough not only in the forensic sciences but also in the field of biotechnology and all other fields. DNA is still used as for the individual typing, and we can individualize a person, identify a person, we can tell the remains belongs to which community, and we can go for the biogeographical ancestry through the DNA analysis. In 1977, the AFIS, that is the Automated Fingerprint Identification System, was developed by FBI and it was automated in 1996. In 1984, Alec Jeffrey developed the first DNA test which was applied to a criminal case. The development of forensic science. The Chinese book Zi Duan Yu, The Washing Away of Wrongs, which appeared in 1248, provided the first association of medicine and law. The book offered useful advice such as distinguish drowning, water in the lungs, like the person was drowned before murder or was drowned after murder, and the strangulation, like the pressure marks on the throat and damaged cartilage in the neck from death by the natural causes. Matthew Orfila, he is one of the major figure of forensic science. He is also known as the father of toxicology. He worked in Paris and testified in an arsenic poisoning criminal trial in 1840. Orfila and others had developed a chemical test to detect arsenic. It was the poison of choice at that time because for that period the symptoms of this poison matches with the symptoms of cholera. That means they have violent stomach pains, vomiting, and these symptoms, the arsenic poisoning symptoms, were similar to the cholera symptoms. So this poison usually got undetected. Matthew Orfila he worked in the field of toxicology and he identified the arsenic poisoning. Then we have Alphonse Bertillon. He devised a system for personal identification using a series of body and facial measurements for individualization. This was the first identification system using bodily measurements known as anthropometry. The Bertillon used this system where we have the total height of the person, where we have various identification marks like the distance between the two eyes, like the distance between nose and the mouth, the distance between the forehead distance. So all these distance are measured by the Bertillon system, and these anthropometric measurements are still used in the case of forensic science in the field of forensic anthropology. Edmund Locard was a French criminologist. He was the pioneer in forensic science who became known as the Sherlock Holmes of France. He formulated the basic principle of forensic science, every contact leaves a trace. This has gone and become known as the Locard's exchange principle. This principle is the basis of forensic science and we commonly use principle of exchange or the Locard's principle in the forensic science law. Francis Galton, he conducted the first definitive study of fingerprints and their classification. In 1892, he wrote a treatise entitled Fingerprints. The various classification done by Francis Galton in his book Fingerprints are still being used and still being followed by the various fingerprints experts to know the various classification of fingerprints like arches, whorls and composites, loop, etc., which was developed by Galton in his book and written by Galton in his book entitled Fingerprints. Leon Letters, he developed a simple procedure for determining the blood type A, B, O, AB of a dried blood stain in 1915. Carl and Steiner discovered blood groups in 1901, and Leon Letters further, he provided a simple procedure to analyze these blood types. Calvin Goddard, he is known as the father of ballistics. He used a comparison microscope to determine if a bullet was fired from a specific gun. He published study of tool marks on bullets. Osborne, he developed fundamental principles of document examination. He wrote a book entitled Question Documents. He was responsible for the acceptance of documents as scientific evidence by the court of law, which was a major discovery in the field of question documents. Thank you so much.